On seeing the beam layout or the column layout, that is the sketch which indicates the bending moments, maximum bending moments in the beams, we find that the maximum bending moment in the horizontal lines is 147.83 and next is 101 kilonewton meter is the bending moments. Likewise, the other bending moments are indicated here. Likewise, in the vertical lines, the maximum bending moment in the vertical lines is 89.79 kilonewton meter. And next is 74 something. And the likewise, the ranges from this to from this has been named as group 1, group 2, group 3, etc. For the difference between the group 1 to group 3, we can assume it as a difference of bending moment of about 25 kilonewton may be assumed because the reinforcements may differ at the range of 25 kilonewton. So this has been grouped in this way. This is for the convenience of designing because we cannot go on designing the beams for whatever the number of beams available in the sketch. So we have divided it into 9 sections. Actually, total beams available in this is about 20-25 beams are there. Actually, we are going to design these things. Microsoft Excel page. In this, we are going to design the building, design that beam using formula bars. Then any number of beams can be designed at an easy part. Group 1 we are going to design now. The maximum bending moment is 147.83. We are going to use this SP16 which is nothing but the design aids to IS456. Now we are going to design this using the formula bar method. This is 147.83 is the maximum bending moment. Uh, This has to be multiplied by 1.5 for the finding the factored moment. We should design, but the factor set should be included. Including this, this is this. How this comes? This is this much into 1.5. This I have fed in formula bar. See here, this is the formula bar. I have fed like this. M20 is the concrete. Fe500 is the steel we are going to use. Breadth of the beam is 230 mm. We have already decided, assumed. Depth is 450 mm. We have assumed. D dash means this cover to reinforcement. This is 30 mm. We have assumed. For please note that for coastal areas this should not be 30. This must be 35 mm or 40 mm as per IS code. For due to this saline action or sulfur action. In sulfur action also we should use this as 40 mm. Salt action, okay. The effective depth, this ratio, so effective depth is, this also have been fed in the formula bar. See here, this is this one minus this one is here. Okay. D dash by D is this calculation is to be made for using the tabulation in IS456 design aids. This mu by BD square is also required for using this tabulation. This has also been made in the formula bar. See here. This means mu means this is mu is maximum bending with the factored moment divided by this breadth 230 and d square. These things, if you double click this, these things will come up here. Now we are going to use this book. Refer the book. Refer tabulation 54 or table 2 of design aids IS456. This either these two tables, whichever is applicable, we can use. For some of the factors, we can use this 54. Some of the values of mu by d square, this in tabulation 54, this will not be available, so we have to use the tabulation 2. So that if you see that book, you will understand. For the d dash by d value of 0.07 and mu by d square value of 5.5, we are going to design we are going to find the percentage of reinforcement by using this table 54 of IS 456. That we shall see. Okay, this is the tabulation in IS 456 design aids. This is FE 500, FCK 20. The tabulation is tabulation 54, reinforcement percentage for doubly reinforced section. That is, we are going to provide the compression reinforcement and the tension reinforcement. For this, d dash by d value is 0.5 is available in the tabulation, 0.1 is available in the tabulation, but our d dash by d value is somewhere in between these two, which is 0.07. For that, we should calculate by interpolation method. Okay, this value we should make an average or some distribute equally between these two. This is the value of tension rod reinforcement percentage. This is value of tension rod reinforcement percentage for 0.1. This is 0.05. In between these two, the reinforcement percentage will be there, as well as for the compression reinforcement also. This is for compression reinforcement. Sorry. This is for compression reinforcement for 0.05 d dash by d value. This is for compression reinforcement for this d dash by d value of 0.1. From these two, we should interpolate and find the required value for 0.07. On interpolation, I have found this as 1.46 for as a tension percentage, tension rod percentage, compression rod percentage is this one. Okay. Now we have to choose what is the diameter of the rods required to be provided. For midspan, these moments are, we have taken these moments as the midspan moment where the maximum bending moment will be available. So from that, the area of cross section, totally, this is only percentage. What is the total area of cross section? This is the total area of cross section required to be provided in the steel as a steel. Now, how to find this? This is cross-section area of concrete into percentage of steel, percentage of reinforcement. That we have this I have given in formula bar. See this. For the persons who knows this Excel formula, we know this. Others, please note that this is total cross section of the beam into percentage. Or total cross section means it is that the depth is to be required as to be concerned as the effective depth, not the total depth. Choose the rod using the area cross section of different rods. This is the 8 mm rod. This much area cross section of each rod, 10 mm, this much area cross section, likewise 8 mm, 10 mm, 12 mm, 16, 20, 25, 32 mm diameters. These are the area cross section of each rods. From this we are arriving that 3 number of rods in 25 mm has to be provided. 3 numbers means 25 mm 490 into 3. This will come as 1471 square mm. Whereas our required area cross section is 1410 square mm. In between these two, this is the maximum nearest and in the higher level area of cross section required to be provided as a tension rod. This is a sagging bending moment. This rod has to be provided in the bottom of the beam. Coming to compression reinforcement area cross section is this much. As already we have decided, this is the percentage required to be provided in the cross section. In this, by calculating that the area cross section into percentage, this is the value. This is the square mm required as the compression reinforcement. This rod is to be provided at the top of the beam. From this area table of each rods, we are arriving this as we are going to use two number of 25 mm diameter rods. 2 mm 2 rods. This is 490 into 2. The total is 981. Whereas required area cross section is 724.5 square mm. nearest is this much. For end span, we are assuming that the maximum bending moment in the midspan and maximum bending moment in the support are the same. We are assuming this. So, end span at support, some rods, same rods are adapted as provided in the midspan. So, tension rod where in the midspan, whatever the rods come in the bottom will become the rods at the top. Whatever the rods coming at the in midspan will come as top rod at the end span. This we have provided this. Here we are required to note that the T beams are not adaptable in any continuous beams because the T section that the flange should be available only in compression area. If it is taken that only this can be applicable only in the midspan. If it comes to end span, the flange is there in the tension area. So we need not have to worry about the flange availability. We can design as rectangular beam only for any continuous beams. So far we have seen the design of RCC beam using Excel method, Excel formulas and IS code books. For we having used this Excel sheet, Microsoft Excel sheet, now we are going to see that how fast we can calculate the reinforcement details for other beams. Okay, this is beam group number 2 we are going to calculate. The bending moment in this group 2 is 101 kilonewton meter. This maximum, that is the factor moment, has to be calculated based on the previous. We will copy this and paste it here. This will automatically give this factor moment by multiplying the above value by 1.2. Here the length, breadth, depth, etc. similarly as we have given in the first B. Calculate the d dash by d. Copy and paste it. This also gives the same value because the depth, breadth, everything are same. Now the bending moment, the mu by bd square value, as we calculated previously, we are going to do the same thing here also. Paste it here. This mu by bd square value, this comes as 3.73. Again, we are going to use the same table 54 or table number 2. On calculating these things with the use of IS 45654, I am getting this value like this 1 point. This value we are required to see the book and we have to fill it up. Then for the compression reinforcement, this has already come. This tension reinforcement has already come up by the calculation by Excel. Compression reinforcement has also come up based on this Excel formulas. The number of rods I have suggested this much. For this also, for the I have suggested this one. In the midspan, as per the present design, we are using two number of 20 mm diameter and one number of 25 mm. Total area of cross section 1118.6 something. Required is 972. This provided rod is little higher than this one required number, so then it is okay. Similarly, for the compression reinforcement, I have designed as suggested as two number of 20 mm rods only. For this, the 350 something is required. 626 is the proposed square from, because we cannot change the diameter in the corner rods So putting the same corner rod, the square mm comes little higher. There is no problem in it. There is no way also to reduce it. Similarly, for the end span also, the same thing, same rod, similar methods I have adopted. The rods are coming like this. By this way, we can go on using any number of beams in the same method. Next video, we can go and see the design of beam for the shear force, that is for the rings and stirrups. We shall see in the next video. Thank you.